Are things working? They seem to be working. They seem to be working. When I say they seem to be working, the mic also seems to be working. Wonderful. Okay. So, what was I going to do today? I think the main thing that I was going to do today is just like, have a chill time going over some old pull requests, just random items to do with like MATLAB, for example, that I'm wanting to handle, and just like get things into a nice state. I mean, so like for example, if I go to MATLAB, the GitHub repository, this one, I'm signed into GitHub, and I go to pull requests, and I go to author Bolton Bailey. I see that I have many pull requests here, and it would just be nice to like get more of these in a awaiting review state, maybe like close some if they're if I decide it's like not something that's ever going to really happen. And so that's what I thought I would do right now. But first, I look at this. Okay, so yeah, why do I have this open? The first thing that I immediately remember is that I was thinking about actually making a new pull request. What was to do with this? Basically, there's this. It was on terminal. No, this isn't it showing. It was something that Yale had sent. If I search. This error, yes. So I wrote this janky Python linter to detect non-terminal simps, and it was causing problems because I think that what's sort of happening is that people are deciding that sometimes they do want non-terminal simps, so they want certain tactics to be allowed after calls to simp. Certain like quote-unquote flexible tactics. And ASOP was one. And here Yale was complaining that they couldn't get, like they had some code which was getting linted when they didn't want it to be, and now it's also because they were using ASOP, right? And so what I did is I went, and I added this like clause which basically says, okay, do not do anything if ASOP follows the simp, but still problems are coming up. And so maybe I can make this, so obviously I had made a new branch for that. So if I go back to the master branch, I think the thing is that it already got merged. All right, so here's linstyle.py in the master branch. If I sync, will it immediately reveal? Yeah, so I sync and you see that this has already gotten merged, hooray. So I'll restart lean, but now there are problems with other ones, and so maybe it would be better. Flexible tactics. So what I'm thinking is instead of that, I want ruffle ASI. I just want to declare some list of flexible tactics. They include ASOP, they include Omega, and they probably include a bunch of other things as well, which I had accessed. Like if I go flexible versus rigid tactics, is there like a big list somewhere? I feel like there was one thread where everyone was voting on what they wanted to be flexible. Flexible versus rigid. It'd be nice if there were just like a list. It would also be nice if people would just sort of like, decide. exactly, because probably there's like still some controversy over what exactly should be considered flexible. Flexible tactics, yes. Flexible versus rigid tactics. There's some, I swear there was something where there was like a large vote on a whole bunch of simp followers. Maybe this is it. Yes, okay, here. Wonderful. And so there are some things that people generally agree should be allowed after simp and some things that should not be. So it seems like riffle, simp, maybe ring, Aesop. Okay, so put in ring here. Aesop, Tado. Okay, apparently I voted for Tado, but it does not seem to be wide agreement on that. Norm num. Positivity. I guess I'm going with the ones that are above 4. Positivity. Able. Bubble. And Omega. So this seems like a good list. And so what I want to do is lint. So basically what I want to say is if any of these tactics or any F in next line or F in flexible tactics. Yes, this is a massively long line. No, I don't really care. Right, so if any or ruffle in next line. Okay, so right. So I don't need ruffle it. I don't need to check ruffle in that because it's much better to do. I'm already checking that. Or any F in next line for F in flexible tactics. Next line starts with pound sign. When does the next line start with a pound sign? I'm not exactly sure. Right. But this seems like the correct thing. And so obviously we don't want to put this in master itself. What we want to do is make a new branch. Bailey slash terminal flexible. Enter. And we can just go and open that again because this is fine. This seems right. If any of the flexible tactics, if any flexible tactic is in the next line for F in the flexible tactics, then this is not the case. Right, that seems correct to me. Okay, I'm going to add this as a tactics publish branch. Okay, now that I published the branch, I can refresh this page. GitHub will be like, yo, you want to make a pull request? And I do. Maybe chore. Add flexible tactics to terminal simp. Enter. This PR makes it so that the non-terminal simp enter the existing string-based on-terminal simple linter will not trigger when a simp is followed by one of a few quote-unquote flexible tactics. Okay, we made the pull request. Okay, so this will now run. There's only one file changed, namely this file. I think that this is like totally acceptable Python, right? To declare some like constant outside a function. Yeah. Okay, so that seems fine. The pull request number is 12663. So I'm going to go back here, and I'm 12663. And I'm going to say, okay, I made this to exclude several more flexible tactics, including omega send 1263. Yeah, that seems fine. Labels are awaiting review, awaiting CI. Because I don't think I have to do anything else here. And awaiting CI, it has to await CI, that's totally fine. Okay, cool. So we accomplished this, hooray. Now, I'm gonna just move on to some other pull requests. So if I go back to my pull requests, authored by Bolton Bailey. So basically the ones that I'm looking for are the ones that are not marked awaiting review. Because the ones that are marked awaiting review are awaiting review. I don't need to necessarily do anything else on those right now. So the next one I see is this one. Click. It says that it is blocked. It's blocked by format table. Right. Yes. So this has to do with the longest poll script. There's this executable that we have now called longest poll, which prints out some data about what the longest poll is, and that means like what is the like string of imports, which in the like massively parallel setting is like most bottlenecking the like final compilation of the entire MATLAB. So why don't I click on this one, right? So this one seems like something I have to do. Okay, so I'm just going to copy this, and I'm going to go to, sorry, how do I go to check out that? Just like it is synced with the GitHub, I believe, right? Restart lean, sure. And so what is the nature? Okay, so what have I done in this, right? So this, right, this pull request also has to do with the longest poll executable. So this is the longest poll executable here. It exists as a file, in like some subdirectory of the top level directory, right? So if I like go and identify it, right, it's here. There are actually, like, it was just before it got merged, it got split into two like there's one that deals with the API for the speed center, like it gets all of its data, this program, from this like service that like speed tests MATLAB. But what I want to do, right, if I look at how I've changed the file, what I've done is basically what this is supposed to do is it's supposed to like print out a table. And what I have made it do is I've like extracted the table printing functionality as its own function, which I call format table. And perhaps it should be put in like a different file as well, because it would be nice. One like nice possibility is that this could be like a general sort of table printing facility for anyone who wants to print a table. So let's see if it works. Like xe poll. Yeah, like I use like it, so it auto-completes poll, but you can't just press tab. This was something that I installed in this like weird, I I like got a little too excited one night, and I installed this special terminal theme, but I don't know how to use it yet. So we're running Lake XE-Poll. What will happen? Presumably what will happen is it will tell me that I have not run, yes. So what is happening is that it could not find run. And the reason it could not find run is because currently I am in this this pull request, right? I'm in this branch, and the speed testing service has never run on this branch. Well, it has run once on this branch, but the annoying thing, so they ran once, but the annoying thing is every time you make a new commit, it changes everything. Like, one nice facility could be to just like, please go to the commit, the most recent commit, which is you know, like some commit which is like the most recent commit to have a run for it. But if I want to be able to, like, okay, so I think maybe it's somewhat critical for this, for working on this, is to be able to actually like see the output. And maybe the easiest way to see the output is just to get the benchmark bot to run again, so that it's, you know, running. And I just have to remember to like not make any commits, which is a little annoying. Yeah, so perhaps a even better pull request would be to just like fix it so that it can run on old commits. Yeah. But that is maybe something for another day. Right, so this is awaiting. Right, what is this awaiting? This is awaiting the benchmark. And so, like, unfortunately, this is not something that I can move to awaiting review now, because there's still things I want to do with it, right? This is more like a work in progress. Because there's things I want to do, like I want to make it so that this table function, where is it? This format table function, I want to make it so that it can, like, you know, supply, like, you know, what column, like how to like adjust the columns, how to justify all the columns. Like, basically, like one like fun idea is it would be nice to make this so that it would like output tables in like a markdown compliant format, so that you can just copy and paste tables into a markdown. I guess I'll like add that. Edit. To do. Make formatter output tables in markdown compliant format. Seems good. Why is this under? Huh. Yeah. Okay. Update comment. That seems fine. Okay, cool. But we can't work on this now because we need like we need the speed tester to run. See, the speed tester like has kindly let me know that it is going to work on this, but it's going to take some time for it to complete its, like, how long did it take previously? So I made this commented 4 days ago at 3:51, and then it responded at 4:16. So like half an hour or so for it to like run the benchmarks. Cool. Great. Okay, so that is in progress. Basically I was looking at, no, okay, this is the one that's blocked. The one that's in progress is down here somewhere, presumably. I don't know where that one is. The formatting table one. This one is the one that's in progress here. If I refresh, presumably it'll say that it's work in progress. Cool. Okay, so let's look at this one. What is this one? Perf. Move powers lemmas into group theory exponent. Ah, okay. So I think that this was a pull request that I had made to try and shorten the longest poll, right? The goal of the longest poll, let me like actually go to the longest poll just so that people who might be watching, who aren't familiar with it, can see the long poll. You can see what the output is supposed to look like. The output is supposed to look something like this. Right, I can even like increase the size, right? If I like show the output looks sort of like this, and it displays, right, the like list of imports, right? So MATLAB number theory cyclotomic PID imports MATLAB number theory cyclotomic rat, which imports this, all the way down the chain, down through like the standard, the std directory, down to like data list basic here. And you can see how many instructions each of these files took to run. And because each one imports the previous one, MATLAB can't possibly like compile itself in a time shorter than this sort of cumulative top level number, which is currently around 500,000 instructions, or 5 million instructions, or 5 million million. I think these are millions of instructions, not thousands of instructions. Yeah. So this is like 5 million instructions, and it takes this much. And so like a nice sort of goal from multiple perspectives, it's like a nice goal to try and like lower this top level number, right? Because it means MATLAB will probably compile faster if we ever get parallelism really working well. And it also means that just generally it's the case that things that don't need to import something else don't import something else. That just makes it sort of like better organized, maybe, in a sense. And so that's why like it's sort of a nice goal to try and get this number down. And so the thing that I'm looking at now is some pull requests that I made that attempted to do this, right? Zmod, quotient, and group theory exponent. This is obviously like a pair of things that imported each other. And I was trying to see if I could get them to not import each other by sort of moving some things from one file to the other, I think. But I think the issue, like if I recall correctly, this just sort of did not work at all. The issue was that like I still had to import the other thing, and it wasn't like sometimes you can sort of avoid importing by like, you know, grouping things. Sometimes a good way is to just like cut a file in half so that, you know, like things don't have to use the second part of the file. You can just make the second part of a really big file into its own file that, you know, you import it if you need it, but most things won't need to import that long second half. And you can make things faster that way. I think what I'm just going to do with this is like just close the pull request. So because it was like nothing was really working out here to make things faster. This didn't really succeed in making in removing any imports. So I am closing it. Close with comment. Wonderful. And like, you know, if I ever go crazy, I can start reopening it, maybe. Okay, so if I refresh, presumably that will disappear. Okay, we looked at this, we looked at this, we looked at this. Feat, add tropically bound polynomials. Ah, this is the thing that I discussed in another recent recording that I made. So if I click on this one, yes, this is what happened. I did some work on this, and then I somehow deleted everything, and then I went to work on it again. So the thing I did, basically the point of this pull request was to add a feature to MATLAB. See, I don't, part of my, like, if I can go and open, sorry, let me find the project in which I was working. It was this project, and it was this file. And in fact, it was more than just that file. It was actually something a little bit. Shut that down, shut this. Computable types, it was this. Here, let me put this up on the screen. So I had this like whole file. The whole point of this was to just make a version of polynomials that operates purely on the basis of a list. that would be computable. It would be possible to like run computations on this type, unlike normal polynomials. And so the question is basically, right, and what I was sort of trying to do at some point was this, right? So I have it commented out because it was causing massive problems, which is annoying. But it's like an instance of this one weird bug, right? Like if I mouse under here, it says declaration uses sorry. If I delete the sorry and I try to actually complete it using sorries here, I get this thing which says compiler IR check failed, unknown declaration polynomial to probably bound polynomial, which is weird because that function is definitely defined. This is definitely like a bug in Lean 4 that other people have experienced as well. So yeah, like there's a, if you like go on, if you hunt around on Zulip enough, you can like find the Lean 4 issue for this particular bug, and you can like upvote it so that they'll maybe fix it faster. But yes, so this is definitely like some weird issue. The issue is that this is like non-computable. Like if I change it to non-computable, it's perfectly happy, but I don't necessarily want to change it to non-computable. So I'm not exactly sure like what entirely is going on. I may like be forced to change it to non-computable. I just don't want to like deal with like the semi-ring instance right now because I just want to like, you know, prove things later. But I have all of these things. I mean, so one like thing I was sort of questioning myself is like, is this something that I even necessarily want to put inside MATLAB? Because I feel like MATLAB has definitely got a philosophy of like objects should, like computability of objects should never come before ease of use. And I find it hard to think about like whether if I do put this in MATLAB, is it going to like, is somebody going to come along and make it uncomputable or ask, what is this for? We already have a polynomial type. So there's like a strong possibility that this whole thing should be, that this whole thing, is this non-computable instance? Right. I mean, this thing references, right? The point is that like this section of the file is something that Junyan Shu wrote. And we have like several non-computable instances in here anyway, so maybe this is something that's worth, I mean, the point is just that this is something that like someone wrote that I was going to use as like a sort of lever, right? I think it makes sense at the very least to put this content into MATLAB, because like if I'm going to be leveraging theorems and the polynomial like type from MATLAB anyway, then this will necessarily, like any place that I do that from is necessarily going to have to import MATLAB anyway. And so therefore it makes sense to like one concept is like basically the thing that I was attempting here was to prove that the type I made was a commutative semi-ring on the basis of this existing proof that this type, which is basically identical, is itself a commutative semi-ring. And the proof is like, the proof of that is somehow non-computable. Non-computable instance. Right, it's a non-computable instance, of course, because addition, right, inside the definition of commutable semi-ring is an addition function. And that addition function is not computable because it has a polynomial. So there's no way that this content can be made non-computable. So I'm just going to like copy this. Right. So if I go back over here, right, I'm in this, sorry, let me copy the name of, instead of copying that, let me copy this. Let me go here. Tropical poly, yes, so I have this. And there's a file name, which I will now copy. And the file does not contain anything. But if I go here and I copy this, I can return here and paste it. And obviously, so like obviously the other thing that has to be done is I have to put all of the right data. So what is the data that needs to go here? Okay, so Junyon authored this, but I like this is supposed to be where you put the name of like the corresponding author or whatever. So I'll put my name there so that they don't necessarily get bothered about that. I'm going to put my name here too. And Junyon's name. And obviously this is a 2023 or 2024. I don't know what the year is supposed to be. Okay, the other thing we need is a bunch of MathLib imports. Imports are out of date and must be rebuilt. Restart file, yes. Restart lean. Yeah, basic. Tropically bound polynomial, or maybe like degree bound. See, the thing that is in MathLib, if I go to docs, no, it was, yes, I'm forgive me, I meant to go here. There's definitely something as like a degree LT, this type, right? There is actually a type of those polynomials which have degree less than something. They are a submodule of polynomials with degree less than n. What I'm talking about here is not this submodule, but in fact, submodule. Yeah, what I'm talking about here is not a submodule of polynomials, because it's actually like a different underlying type. What I'm talking about here is the type of polynomials that have a bound. Like they're augmented with a degree bound. I'm not exactly sure what the best way. Maybe like degree bound poly is the best way. I guess we were calling it tropically. I mean, like what this sort of suggests is that the name of the file should be the same. Tropical polynomial rename. If I rename it to this, tropically bound polynomial. Restart file. Yes, so we have these instances, but I think everything here in theory should compile fine. Okay, so it's like compiling. I mean, like a faster way of getting this to compile would be to pull from origin master. That merges everything. We can recycle things. The lean version is changed. We can restart lean. We'll restart the lean language client. Yes, and things will not be the input. So what we want to do now is to fetch the build cache, which I believe now that I've pulled master will fetch the master build cache. Because this is a totally new file, in theory, it should build very quickly. Checking MathLib build artifact cache. Okay, well, this is working. I'm just gonna leave. Wonderful. It is not building anything at all. Restart the file, please. Okay, what is it complaining about? It's always concerning that it says there's no messages. Computing build jobs. What is the, do I have to press restart file or something? Why is there an issue? Build failed. Okay. I don't really get that. I mean, one thing that has to be done. MATLAB Algebra Tropical is like whenever you make. Sorry. Okay, maybe the easiest first thing to do is just like add this file. Add the file. Commit. Changes. Now, when this happens, whenever you add a new file, you have to add it to mathlib.lean. So there's a top level file called mathlib.lean, which consists of all these things. And the thing that I'm importing is called MATLAB Algebra Tropical Tropically Bound Polynomial Basic. MATLAB Algebra LMNOP Algebra Tropical LMNOP. So I think what I have to do is element Q. Tropically bound polynomial. Lattice. This seems right. Okay, add mathlib.lean entry. That, shut that off. Okay, so yes, go back to the conversation. I did this, and it's building. And like was there something it was complaining about? I'm not exactly sure what it was complaining about, but maybe the best thing to do for now is just label it as awaiting CI and awaiting author and let it cook. Okay, cool. I'll go all the way back. Okay, cool. That seems fine for that. Well, it's always weird how GitHub doesn't like show you the things, show you the little additional things until it. All right, my next thing is Berlekamp Welch, which is in progress, but I decided that I needed like extra additional linear algebra facilities in order to be able to do that. So I think I'm going to put that on hold too. This one is already awaiting review, so that seems fine. Let me look at this one. Feat scripts to analyze overlap between namespaces. Yes, and I have some to-dos here, right? So if I look at this, what is the name of this sum? I'm just gonna like quickly move over to this branch. So I have something called record namespaces. Yeah, basically I sort of envisioned this as something like a little bit similar to longest pole, right? It's just a way of analyzing some namespaces. And I wrote this whole thing in Python. So like Flores constructed this for me. Let's like open the let's open the files that have been changed. Record namespaces.lean. And then a Python script which calculates the overlap between namespaces. And what I was doing a lot of was, I guess I was making pipeline plots. Yeah. Well, not necessarily optimistic about being able to plot things in Lean. just like constructed some file. See, this would be a nice thing to do once the which would be a nice thing to like do once the table, right? The table facility, because what I was basically doing here is making a big table of like what are the namespaces that overlap the most. Like the polynomial and the multivariable polynomial namespaces overlap a lot, and they have a lot of like similarly named lemmas. The same as for like top and bottom and like order, like ring and semi-ring, right? All of these namespaces that overlap a lot. So for that reason, it seems like a good thing for this to like depend on would be the ability to like make tables, because I would like to make, if I'm not going to make a plot, I would at least like to make a table. And so maybe another thing that I can do here, translate to lean, put in utils directory. So just let me duplicate this tab, because what I want to say, right, where's the table? Go back, format table. 12, 1, 2, 3, 2, 2. Okay, so if I edit this, I'm going to copy out this thing so that it'll depend on that. 1, 2, 3, 2, 2. When this is rewritten in lean, it would be good to output this in the form of a table. Data in the form of a table. So I'm going to make it depend on that, mostly so that I don't have to like think about it until some other pull request gets the bump. Right, that seems fine. Okay, so lots of things going on. We did that, yeah. So which ones have we looked at now? Scripts to analyze the overlap between namespaces. That's the one we just did that for. I guess, is it not going to run because it's a draft PR? I think I would like it to not be a draft PR, so that it at least gets the label. The bot will run on it and look at labels for it. Okay, so that seems fine. Scripts to analyze overlap between namespaces. Lemmas on polynomial singleton quotient. Right, so this one is awaiting review. This one with all the option equiv lemmas is awaiting review. File for lemmas about MV polynomials over no zero divisors. Yes. Right, so what is the content of this file? See discussion from 11073. If I recall, basically this was some, yeah, so I had added these two lemmas, which say that if I have, if I multiply a constant polynomial by a polynomial, then the degree of some variable in that, so these are all multivariable polynomials. And let me just see what I added in this. I have some multivariable polynomial, and I multiply it by a constant polynomial. And then the degree of a particular variable in the resulting polynomial is less than the degree of that variable in the original polynomial. The reason why it's not equal is that c could be 0. That c could be 0, and in fact, furthermore, that we could be living in some, right? The other possibility is that we could be living in some domain where, some non-domain, non-integral domain. We could be living in a domain with 0 divisors, where like if I multiply something, it like comes out to 0. I multiply some non-zero thing, it comes out to 0. And that was probably causing me like problems with the generality. I think this is the main comment, right? Can you generalize this to integral domains? Right. Wanted me to generalize this to integral domains. Section field. Did I? Okay, maybe the issue was that I added more, sorry, the things that are showing up here is not all of the things that I was originally going to add to this PR. There were other things that I was going to add. Let me like click on this and see if I can see what I was going to add. So I did degree of CMOL. Okay, so I added this, degree of CMOL LE. And I had additionally put in this, right? This is like going to be a nice simp lemma. The only issue was that I was not going to be able to apply it, right? So I wanted to add this lemma, which is MV polynomial degree of CMOL, right? Which was a lemma that says if I'm in a field, right? If I am in a field and C is not equal to 0, if those two things are true, then the inequality that I described earlier is in fact tight. If I take the degree of some polynomial times a constant, non-zero constant, then it's just the same as taking the degree of the base level polynomial. And what the reviewer helpfully pointed out was that this should be true in integral domains as well. Because if it is simply the case that we're in an integral domain, then there's no zero divisors. It should be true if there's no zero divisors, right? Sorry, integral domain and no zero divisors are slightly different concepts, I think. If there are no zero divisors, then whatever the degree is that is causing the degree of this to be large, then when I multiply by this non-zero constant, it will still be non-zero and we will still have that degree. And I guess what this does is it takes us back to this new pull request where I add this file, multivariate polynomials over no zero divisors, where I need to add this lemma, right? If I multiply some constant, so wait, let me go back here. I think this is the theorem that I'm trying to prove, right? For some reason, I don't have it here. Sorry, let me go back here. Let me get the name of the branch. This is the name of the branch. Why is there, see, like, what is the deal here? Why are there all of these files that have a 2 after them? This is something that I would like someone to explain to me / fix. Because they're not like relevant to me at all. I just need to delete them. So I would like to go here. And in particular, I would like to go to the file, which is named this. So what we have here is a bunch of lemmas about the degrees of various products of polynomials. There are several notions of degree for multivariable polynomials. There's the degrees, which is like multiset. There's degree of, which is for a specific value, and there's total degree, which is the sum of all the degrees. Total degree. Wait a minute. What is total degree defined as? Total degree. Is that like the maximum number of variables, the maximum S over the monomials? Yes, okay, that makes sense. But if I go back here, degree of CMOL was a theorem that I wanted, and I wanted this theorem. So this is what I wanted to be here. Degree of CMOL is this. Restart lean, because the lean version has changed. Lake configuration. See, this is another case where it's sort of like add theorem. Statement. Cool. Commit that. Sync the changes. Then we can like pull master. There are merge conflicts. Really? There are merge conflicts. Ah. Yes. There are merge conflicts. Namely that everything should be in algebra. Right. Everything about multivariable polynomials got moved out of data. Sorry, I'm a little confused here. What am I looking at? MATLAB data. Imports are out of date. The issue is that this file should not exist because it's in data. And it's deleted, which is correct. The thing that needs to change is that this needs to be algebra, I believe. It seems to have this. What is the merge conflict, though? Can you explain what the merge conflict is, though? This is such a... Git is so hard to use. Like, what is the problem? No zero divisors lean MATLAB. What is the actual merge conflict? There's no merge conflict in this file. Like, usually when there's a merge conflict, it like displays you that there's a merge conflict. Sure you want to stage? Are you sure you want to stage, but no merge conflicts? Resolve get merge, but still says unresolved. Usually we'll get merge conflicts. It's not updated to get merge conflict resolved message. Okay, what happens if I just say yes? And I commit. And I sync the changes. Okay, now if I go to here, what happens? What does it say? I have a file. Like if I go to the conversation, files changed is this. I think everything here is okie dokie, right? It's like this is the form that I wanted things to take, right? I want to delete this file now that it no longer exists. Okay, but now what I want to do is I want to get the build cache. Checking MATLAB build artifact cache. I have like, do I have to update lean, string lean? Yes, cool. It's happy. Except that it's not happy about the definition I just added because I called it F when I should have called it R. Yes, that is perfectly acceptable. F to R. Good. Okay, so I wonder if I can like prove some of these lemmas. One obvious point is that we're in the polynomial namespace, so we can like so one thing we can do is instead of this, we could be doing a lot of things in dot notation here. Whatever. People like dot notation, they can tell me to do dot notation later. Right. Sorry. Okay, and if we make this larger, and sorry, open the, we can like put our cursor here and see that we're in theorem proving mode. Yes. Okay, cool. And we can like prove here as well. So like maybe, yeah, so maybe I'll just like try and prove these lemmas. P times Q dot degrees equals P degrees plus Q degrees. is this statement even true? So degrees is a little bit different from the other one. It's not the sum. It's like the total degree is not actually the sum of the degrees. Right, the total degree, the definition of degrees, it's the maximal degrees for each variable expressed as a multiset. This is hard for me to it's hard for me to think about whether or not this is true. Right, so it would be true. What is the definition of degree of? Degree of gives the highest power of xn that appears in it. Is it just the like, okay, wow, page not found, cannot find a valid ref. What? Okay, this is definitely a bug. Am I not in the default branch? I'm confused. Okay, I can click equations and see what the equations are. Multiset.count, yeah. So I guess the point is degree of. It's interesting that degrees is before degree of. Because you would think that the proof that things are true for degrees is that it's true for each of the degree ofs. 2 degrees are the same. Like I would, okay, so the thing that I basically want to do is degree of x sub. Degree of. So am I right? Am I correct? No, that's not quite right. In fact, this is sort of what I feel like I was making statements about this, right? Does my PR depend on something? Sorry. Lemmas, right. This one. Option, right. So basically what I wanted to, what I did here was, I think, simp obj map. Okay. Yeah, so a lot of this PR was written by someone else. Because it's definitely very category theoretical. But the main conclusion, right? The thing that I was thinking is like, if I think about degree of, right? If I think of the degree of function, right? It tells you what the maximal degree of a particular variable is in some multivariable polynomial. And what that should be the same as is if I separate the variables into two sets, one containing just the single variable that I'm thinking about, and the rest being every other variable. And if I change it into a polynomial over that multivariable polynomial, right? Using this sort of option polynomial transformation thing, it should be the case that the degree of is just the resulting degree. And then so my proof of this fact, degree of n. It's weird that n and m are of type sigma. Like s would be a more appropriate variable. Yeah. But that the way that I would want to prove this fact is I would want to go through that equivalence. Did I not include any theorem in here about? Did I not include any theorem about how degrees interacts with this? Sorry, if I go back, split MV polynomial node variables. Right, the point is that there needs to be another there needs to be another lemma, right? Now that this has been made, right? So the main contribution of this PR was option subtype NE, which is this equivalence. It's an equivalence between a type alpha and the option type over values that are not A. So now that this exists, I think what I want to do is what I want to do is I want to make a new theorem, right? The point is I want to make a new theorem. Now that this exists, section degree of. Okay, I feel the section degree of should be above the degrees section because that was like my plan for this proof. So I'm going to put this here. And the point, okay, this is not something that is, the problem is that this is not something that should go in this file. But there should be a lemma which says degree of is equal to degree option subtype. Ugh, this is degree option. What the copy this word is equal to the degree of the option subtype NE after it has been put through. So I want this equivalence. And I also want the equivalence. What is the name of the equivalence? So let me duplicate this. The equivalence that takes, I think it's MV polynomial equiv. It's like this, option equiv. Right, it's something that takes me from a polynomial over an option type. To a polynomial over a multivariable polynomial. Option equiv left. Okay, I cannot even find, okay, here's the lemma I'm making. Okay, there's a lot of lemma names here. The point, so n is of type sigma, p is a multivariable polynomial. The thing that I am saying is that the degree of n in p should be equal to the polynomial dot degree of the polynomial, which is produced by MV polynomial option equiv left. Option equiv left applied to a particular polynomial. Sorry, polynomial dot degree is unheard of. Where is polynomial dot degree defined? Is it not defined in? Sorry, I need to find the polynomial degree. Find here. Import. Okay, this is going to be pointless. Yeah, like this whole thing is going to need to get moved out of this file at some point. Option degree equiv left. Unknown identifier. What if I import U2? It's just going to import more things. Import. What I need here. Okay, so option equiv left. Option equiv left, yes. polynomial is mapped through, right? So like what I further need maybe the lesson is that I should be doing this in an entirely different PR, because who needs all that? Okay, let me like sync this. Okay, I'm copying this entire file. I'm going back to, sorry, save. No, I'm copying this entire file. I am reverting the file. I am now changing to master, where I'm syncing, and then I am making a new branch. New branch. The new branch will be called degree of eq degree. I have no idea what a I will now go to MATLAB Algebra equiv. Sorry, MATLAB Algebra multivariable polynomial equiv. This seems related to what I want. Except that it's for multivariable polynomials over. Yeah, so basically this is the same thing. Okay, that means this is the right file. I'm gonna paste. So all of this content is bad, but what I want is basically, so here I have something which says the degree is equal to the degree of something, right? And the problem is that it's for this type, specifically for this type of variables, the type of variables for fin n+1, rather than an arbitrary type. Fin_suc_equiv rename fin_suc_equiv. For this an option type. I don't know what exactly is going on here. But basically, okay, I think what I simply want to do, okay, so the lemma that I was looking at, where is this lemma? This is the lemma, right? This is the lemma. I'm copying this up here. What does this end correspond to? Polynomial.degree. So basically what I want is a theorem that's just like this. In fact, I'm just going to copy it directly there. I'm going to copy it directly under fin_suc_equiv. F is not equal to 0. So wait, is this like two parts of the same theorem? Support fin_suc_equiv non-empty. The nat degree of a fin_suc_equiv, yes, the nat degree is the degree of 0 in the multivariable polynomial. So basically what I'm going to say here is this is a generalization of, right. I mean, another good thing to notice is that this is the nat degree. Arbitrary variable types. I'm pretty sure that the rest of this can get deleted because this is from the other PR, right? This is just the whole file from the other PR that I'm gonna make dependent on this one. So I have N and I have P. Sigma. Presumably sigma is fine. Okay. Yeah, like returning to where I was. The degree of N in P should be equal to the degree of the polynomial degree of the polynomial returned by option equiv left for this multivariable polynomial. The one, if I go back over here, that is given. Sorry. I want to map. Yeah, I'm going to have to use the map function. Right. So this is sorry, what is the type here? Option equiv left. Option equiv left requires some like type class arguments, so why don't I provide those? Sigma is the type of the multivariable polynomial that I'm going over. So yes, so option S1R. So R, right, obviously R is just R. R is just equal to R. And S1, no, sorry, I'm doing this wrong. The arguments to option equiv left, the R argument to option equiv left is just R. And the S1 argument, to option equiv left is, it is the thing that the fancy function I have, where is it exactly? It's the one I was looking at in the, sorry, not this one. Yeah, we're gonna be a while until we get to that particular one. This one. The option over this. Right, so S1, right, like we take the option of S1, so the thing that we want to take the option of is this. N, the degree of N. And of course, this should really be A, right? Is the thing, A is the particular value, degree of A in P. If we go back here, the thing that I now need to supply is a multivariable polynomial over this type. And I wish to obtain this from P by applying this equivalence, right? I wish to map through an equivalence, which I assume there's some other function in this file that does that. Maybe it's actually in a different file, like an eval file. Maybe it's eval2. Maybe it's the eval2. Sorry. The problem with eval2 is that it's impossible to search for it. New tab. Docs for this docs thing. Eval mv polynomial eval2. It's not quite like this. MV polynomial. I just want to like change, you know, map. Is that such a thing as map? Maps a polynomial across a ring Hom. No, that's not what I want. I don't want to change the ring. I want to change the variable type. Vars map. That looks right. MV polynomial map. Maps off across a ring Hom. That's not what I want. The problem is like I can do it in terms of a val too, but it's there's probably something more specifically tailored to when I just want to rename. I have an equivalence between two possible variable types, and I just want to pass over that equivalence. Is it just eval? No, eval is that. Polynomial. It's not map, we decided. It's probably like join or something. Eval sub I, perhaps that? Like in theory it would work for any like surjection. Yeah, I have no idea where I am. Sorry. Multi-view, no. Okay, we can just define it in terms of eval to. Eval to. We can at least describe it in terms of eval to, but is that really not? Okay, we can delete this. Yeah. So this is okay. We need a multivariable polynomial over this option type. So we're going to call eval sub 2. Okay, the function which goes from the ring to the ring is just going to be the identity map, which is not, of course, a ring homomorphism. If I go to algebra nv polynomial.monad, is it in there? Algebra nv polynomial monad. I think it would be in here somewhere. Bind 1. Join 1. Ugh, there's so many different freaking names. It would be nice if there were like more descriptive names somehow. Operate on the variable type sigma. Bind 1. Operate on the coefficient type. Bind 1 and join 1. Bind 1 f phi. With f is the polynomial, yes. So bind 1, I mean, isn't bind 1 just equivalent to eval 2? A eval. I heard a notification. What, did I get notified or something? Back to streams. Okay, well, whatever. This or something? I don't know. Deleting this. Okay, don't get distracted. I just want to pass directly. I guess the point is that I have to use bind 1. Like, is bind 1 not equivalent to eval 2? There's a eval. Maybe, okay, wait, maybe I should look at a eval? No, that doesn't look right. Okay, so we're going to do bind 1. Bind underscore 1 of a map from sigma to a polynomial over tau. So I mean, the other thing that I think, can I do like p dot bind 1? Does not contain, yeah. So I need to do bind 1 of something applied to p. Unknown identifier bind 1. Do I need the monad import? Algebra mv polynomial dot monad. It's gonna tell me it's circular. Nope, thank you. Where am I operating? I'm operating here. Do not know how to synthesize placeholder. Yes, so I need this. And I need, well, the thing that I need is a function fun that takes S and maps it to some value, which is in fact this polynomial, and what I want it to be is x of something. X is this, and okay, what's the name of the equivalence? Sorry. Option subtype any. Option subtype is equiv. Yeah, equiv option subtype any. Dot sim of s. Invalid field notation. Type is not of the form. What? Yes. Okay, it needs to be AS. No? Oh, okay, I see. The problem is that this needs to be surrounded by parentheses A. Failed to synthesize decidable equality for sigma. Okay, I'm quite happy to put that type class argument right there. Double equality for sigma. Decidable equality for all. Declaration uses sorry, but that's fine. Okay, cool. Yes, so this is what we want. And what I expect. Rename, is that it? Rename all the variables. Of course. All it took was that. I mean, okay, is this just like the function that I want? Consider a multivariate polynomial phi whose variables are indexed by option sigma, and suppose that sigma is equivalent to fin n. Then one may view sigma as a polynomial over multivariable polynomials. It seems like whoever was doing this is like doing what I wanted to do. Then one may view phi as a polynomial over this by renaming the variables, then singling out the 0th variable, viewing it as a polynomial, and then renaming the variables. I sense that I'm trying to do something that someone else tried to do, but because it is impossible to actually detect when two lemmas are exactly semantically the same, I'm duplicating the work. And clearly what I want is rename and not bind. Option cover. Presumably this lemma is what I need to make the other thing work. Which I now feel a little bit nervous about. Like, how are they doing it? This other, right, a multivariate polynomial. Where is this used? I want to know where in MATLAB this lemma is used. Homogeneous.lean. It's used one other time. So it's very close to being what I want. What exactly is the content of this lemma? And renaming the variables. Consider a multivariate polynomial. An equivalence between, but the thing is, I would like to be able to prove this. Everything in this file that I'm looking at here is for finite types, right? An equivalence to a finite type or fin n directly. But I want to be able to prove this lemma for any infinite type as well. This lemma is true for infinite types. So it's just not, yeah, there's nothing that like requires finiteness about this. Okay, but it is prudent to use rename. Polynomial.rename. How did I not find rename? Where does just mv polynomial.rename? It's in, okay, well, it's in a file called rename, of course. Rename all of the instances, all of the variables. Sure. Okay, so that's fine. What I want is the function that renames the polynomial. And I think the only difference is that I'm renaming s over this function. So there's no need for an x here. And this can be further golfed because I am doing fun s. No, am I right? Yeah, so fun s can be deleted. It's just this. You can delete a pair of parentheses. You can delete a second pair of parentheses. So I think this is the lemma that I'm going for. Okay. Right, okay. Let me take a water. Okay. Okay, so now we simply have to prove this. Easy game. Did I leave the water run? Okay, how do we prove this? I somewhat expect the proof to maybe look a little bit like the other proofs. See, like, the thing about rename, I was definitely like, I feel like it's all coming back to me. It was definitely like in this file. See, there's even a def for an equivalent, like it lifts the equivalence between types into an equivalence between polynomials. I think I may even like want this. The polynomial degree, like the rename equiv. Rename E is an equivalence when E is, yes. So like it would be even better perhaps to call this like the rename equiv. Huh, What's it complaining about? R. It requires R. It's a little dumb. This requires R. This rename equivalence. And this is like a stronger thing, right? There's like in fact an equivalence between these polynomials. I don't really know what I'm supposed to do. Problem is, it's awkward that it's sim. I feel like I asked for this to be the other way, and it was not made that way, but I guess that's okay. Okay, so why is this true? I'm going to have to, like, I guess I'm just going to have to unfold. How is it proved over here? Like, what they rewrite polynomial degree. They rewrite lots of things. Right. Option equiv left. The degree of AP. Yeah, the point is it suffices to assume. No, I'm not. I'm confusing myself. How to rename. Yeah, all these random. Yeah. Like, I don't know how to, like, approach this other than just, like, start renaming things. Start, like, unfolding definitions. Unknown constant. Degree, not degree. I mean, another observation is that this is wrong. This should be nat degree, right? Polynomial dot nat degree. Yes. I don't know if I want to unfold this statement. Degree of x supremum. Yes, sp.support.supremum. Right, so this like clearly we can just take, right, so like the first fact is that the degree of some variable and some multivariable polynomial is the supremum over its support. What I want additionally is the analogous theorem for polynomials. Dot soup. Right, but like basically what I would like to do is identify, I would like to identify in P some monomial that obtains this supremum. And then I would like to like proceed from there. Is there some lemma that says the degree of A in P, like there exists for any P, right? For any polynomial, there exists a monomial such that, such that like it obtains the supremum. Let me just like look at the other FinSuccaQuiv support. Lots of these. Who wrote all these? See, I wrote them. Why was I writing this? No, I guess this is something else maybe. Yeah, very tempted. Like maybe the idea for like proving this for arbitrary types is to like establish some subset. What is the like rename? It's like, because the thing about multivariable polynomials is that there is some like subset, right? There's like, take the subset of values that actually occur. Yeah, seems like a... Yeah, it's just pretty funny that like this is where I head to every time I like want to like the whole reason I'm dealing with these like massive equivalences is because like way back here, where was it? I was here. See discussion from 11073, right? I was here, and I just wanted to add like where is it? This one. I just wanted to add this theorem, right? And it's a theorem that's true for fields, and it's easy to prove it for fields. And then I simply got asked, you know, please prove it for I simply got asked to prove it for integral domains. It was like, very frustrating that it can't, like, that I can't. Can I generalize this to integral domains? It's like, yes, but it will be months and months of work. Yeah, not sure. Not sure what the like. Right, the ultimate. Yeah, frustrating. What did I need this theorem for? What did I need? Did I like? Was it? It sort of pisses me off. This could have been a very important theorem for whatever project I was working on, and it just always gets shut down. I just need to prove that a degree of, yeah. It's for, I know what it's for. It's for my, like the linear P-snark like transformation stuff, which is like all of that's over a field, so it doesn't need this anyway. Just like, it is only because I am like psychotically addicted to proving these theorems that this theorem will eventually get added, and I feel like the community should maybe support people who aren't psychopaths a little bit more in like allowing them to add theorems. Very frustrating. Okay, yeah, what has to be done here is I have to just like unfold lots and lots of lemmas until I like reach the point. Because I was able to prove this theorem, which was sufficient for my purposes, but yeah, it was sufficient for my purposes because it was over fields, and there was a simple proof over fields, but the proof over integral domains is much more complicated. Yeah, there had to be, yeah, it's so interesting how it becomes so much more complex when you, it's because like not all the API is there, which is sort of the irony of this, right? They're asking me to add API. They're just like, improve the API, but I can't improve the API because the API, like, it wasn't improved before. And so it's like, is it truly the best way of going about things to like always make sure that the API is as general as possible? Yeah. Okay. Well, I don't think I'm going to like prove this whole theorem today. And so maybe like my plan is just to like leave this as a sorry lemma for now, and like make the pull request for it. Yeah. Yes, work in progress. Add. Yeah. So basically, I have to like structure the dependencies. Right. To structure like so. Okay. Add lemma to prove. This is what I'm doing. Commit. Publish the branch. Okay. Now I return to MATLAB 4. Why doesn't the GitHub show up? Where is the GitHub? Please take me to the MATLAB 4 GitHub. Thank you. Yes, compare and pull requests. Feet. Add lemma. Oh, how do I even describe? Degree of equal degree. Okay, pull request. Yeah, I mean, like, okay, so obviously I'm beginning to feel that like the proper name for this lemma is just degree of equal degree, because it describes if I have degree of, right, and I want to turn that into a statement at about a degree of some polynomial, the natural way to do that is to talk about this polynomial. And so that is a natural name, I think, for this lemma, nice and short. So this is that lemma. I'm going to save that and say I'm choosing name. This is fine. And of course, build is failing because I have a sorry. Yes, I'm very sorry about that. Oh, and it's also saying that I like have some additional problem. That's okay. That's all fine. I just need this lemma, right? Okay, I can add a description of it later. This is the PR, and the point, degree of CMOL. This, no, this is the PR that I closed. The point is that this depends on this. So I now need to edit. Depends on this. This depends on this. This one. Okay, this. Yeah. Thank you. I wrote it correctly. Thank you. Update comments. So this depends on that. Yes. Now we will be awaiting. We are simply awaiting this one. So it is funny, like I started this, I started today thinking, oh, I'll just like, you know, take care of some of my old pull requests. And the nature of taking care of pull requests is you end up with more pull requests than you started with. This is not related at all to what I was doing. This, the point is that this now depends on this. This, okay. I'm just gonna like quickly fix this. Int. So this is now going to be outdated. I mentioned this pull request. What do I label this pull request as? Okay, this pull request is work in progress. Pull request is work in progress. Yeah. But at least it's, yeah, it's like my sub target or whatever. Yeah, remember. I think I'm just gonna like, because I felt like during the course of finding all that, I was definitely like remembering things from like months ago. I just wish I had like, you have to like, that's the other, like yet another downside of the like really slow review process is that you forget everything you learn every time you have to revisit a really old pull request. So what I want to do is make a note to myself. It's like, we need this lemma to turn to publish like the fact about re of b plus q. That's why we need that. Depends on the other thing. That's fine. And this is another, again, it's like a draft. Oh, but it's even though it's a draft, the bot is working on it. So it's fine that it's a draft then. Okay. Returning to the top level, right? We made, this is all of the pull requests. This is the new one we just made. We also made this other one, which is now awaiting review. This is blocked. This one, maybe we can return to this one at this point because yes, in fact, we have the benchmark commit now. And so we can now return over here and deal with this. If we can remember the name of the branch. Format table is the name of the branch. That's the format table again. Okay, cool. Lean version changed. Restart lean. Okay, what I want to do most of all is get the build cache. What did I do here? Did I delete something that I should have? Save. So this is going to get the build cache. And hopefully what should be possible now is that when all of this is ready, I will be able to create a terminal. And from this terminal, so yes, okay, so this is all built. All right, don't add new things to it. This is all built. We're in the commit. If we run lake exe poll, presumably it will be completely happy to output a table for us. Analyzing MathLab at the hash that we just have the benchmark for. Great. All right, like put this away over here. Yes, okay, so now we have a wonderful table. So what does it mean to be a Markdown compliant table? Right, what I want to do now is I want to like look up what a Markdown table is. Markdown, like what is the format of a Markdown table? Tables Markdown. To add a table in Markdown, use a vertical line to separate each column, 3 or more dashes. All right, so I think it's looking pretty good. The only thing that it seems to be missing, right? So this is very nice, right? I have basically this is, I think, exactly the same format as it usually puts it out in, but I have refactored the format table to be its own little function here, which is nice. So I've refactored out the format table function. The only change is that what I want is the instructions in the cumulative should be right justified. That is something that I want because it makes, if it's a table of column of numbers, it's nice to have the numbers be right justified so the same, you know, so that it lines up, the hundreds place lines up with the hundreds place, etc. So tables, you can do this, but that is not pretty. So I like the prettiness of the alignedness here, right? I have this, the alignedness is nice. We have text alignment. So this is interesting. The column is left aligned, the column is right aligned, the column is center aligned. And it looks basically like we have that. It looks like, okay, so one thing that we need, okay, one thing that I'm noticing that's different from here and here is that there are also pipes down the sides. So I'm going to add that. So what I want is to say that, okay, so this is me constructing the table. I have the padded headers, the padded table. The header line is the intercalation of this with the Okay, so basically I think what I need to do is quote pipe space plus plus string dot intercalate plus plus this. Yes. The same thing is going to happen for each of the separator lines. And also for this thing. Is there a way that I can do this in a more yeah, row lines, padded table dot map? I guess I'm returning, right? It's not that I'm returning a whole bunch of lines. Okay, but if I save this, okay, so I just saved it, and now I'm going to run it again. We'll see what happens. In theory, now there should be pipes down the side. In a way that looks good. Linking poll. Still link the thing that I just wrote. Analyzing MATLAB at this. It's got to retrieve from the speed center all of the data. And now it seems that we have pipes down the sides. Yes. Great. And so I think it is even the case now that I have what is technically a Markdown compliant table. But the other feature that I want is to have this text alignment thing. And so, okay, so what I want to do is I want to supply an additional argument. So I have the headers argument and I have the table argument. What I want to do is supply an additional argument, which is alignments, which is of type option. Okay, we obviously need to do this on a new line. It is of type option, an optional array of alignments. I think this is it not it okay, it's lowercase none. Obviously it has no idea what the type of alignment is because that is not something that exists. I will define that now. Inductive. Alignment, left, right, center. Yes, thank you. That is exactly what I wanted. Alignment. Alignments is this. Unused variable alignments. By default, it is none. So, right, id run.do. id.runDo. If no alignments are provided, default to a left alignment for all columns. Yes, AI, that is exactly what I want. Let alignments equals alignments.getD, array.makeArray, headers.size, alignment.left. That looks perfectly correct. Yes. Unused variable alignment still, but that's great. Cool. Yeah, writing code for me. Okay, so now we have all of the alignments, right? The headers, like one alignment for every header. What I'm not sure is that do we want the headers to be aligned the same way that the entries are? Not necessarily. Of course, it doesn't really matter because the headers are the longest thing. So I think that we'll let the headers remain left aligned. So those are the alignments. Okay, so we have right pad. The thing is we have right pad. Right pad puts things on the right. So if we want to left align things, we use the right pad function. Let padded table. Yes, padded headers. Table.map. Yes, so for every entry in the table, we have for every row in the table, we map that row. Row.map index fun I cell. So we have an fin array size row. So we have an entry in the row. Widths I. Yeah, so we have access to the the widths, right? The widths are we know how wide each row is, and we now know how we want to align each row. So to align each row, we are going to do the following. instead of cell.writePad, what we want is a slightly more complicated function. What we want is if alignments I exclamation point is alignment dot left, then cell padded right, yes, cell dot right pad the widths with I. Yes, looks good. Fail to size instance inhabited alignment. Fail to synthesize instance B equality alignment. Okay, can we deriving inhabited and Boolean equality, please? Unknown constant beak. Sorry, what? Unknown identifier alignment dot left. Sorry, what does it complain about? Oh, it's capital B, capital E. Yes, cool. So we derive the things we need. Excellent. Okay, so yes, returning. If the ith alignment is left alignment, then cell.writePad widths I. Else if alignments I equals alignment.right, then cell.leftPad widths I. Yes, if the alignment is right. Otherwise, we have to do something a little bit more complicated. Because if the alignment is center alignment, what we want to do, if the alignment is center alignment, what we want to do is put an equal number of spaces on either side. So what we want to do, like, is we want to first right pad it with widths I divided by 2. Then we further want to left pad that, not with widths I, but with widths I minus widths I over 2. Yes, so that it's the right number of widths. Okay, so now I'm going to be super fancy. And go down here and fix it. Okay, so obviously we can delete all of this. So we're gonna do the formatting. The format table with these headers and the table, and the optional alignments argument is going to be as follows. It is going to be alignment.left, alignment.right, alignment.right. So this is correct. The right alignment for the instructions column is correct. The right alignment for the cumulative column is correct. And the parallelism would be correct too, but because I want to be extra fancy, I'm going to center align this. Okay, let's see if it works. And it's going to have to rebuild everything that I did, that I just coded. Remember, we absolutely cannot commit any of this until we are done experimenting, because if we commit any of it, it's going to start telling me, oh no, the commit, we don't have any good things for this commit. We don't have any speed for this commit. Okay, and it looks like it did it correctly. It's left aligning these guys. It's right aligning, sorry, if I just expand this. This is a little bit incorrect. Huh, I'm not exactly sure what the bug. There's obviously a bug. Widths I over 2. Okay, at least I got the instructions and the cumulative right. The parallelism it is not getting right. Let me read closely. What have I done here? This is natural division. Computes the result of dividing a by b. For most, a over 0 is divided by 0. For nat and int, a over b rounds towards 0. Yeah, that's fine. Okay, it had it correct before. Right, I'm mystified. If alignment.left, alignment.right, the only other possibility is a center alignment. It's true. Cell.rightpad. The thing I was trying to do is I was trying to first right pad it with some value, which is about half, and then I wanted to left pad it with. Is this right? Width I minus width I over 2. The point is that these two numbers are supposed to sum to widths I. Cell.left pad. Okay, I understand what the issue is. Sorry. Left pad. What does left pad do? Left pad does not just add n things onto the side. What left pad does is it pads you to the width that you want. Okay, I understand what the issue is. Right? Yeah. Left pad doesn't just like the integer, the natural number argument to left pad is not the number of spaces you're supposed to add. It's the final number of spaces that you're supposed to have. So what we want is the length of, so cell is a string. The point is that we want, it's almost like, it's sort of like, do I even want to use, if I go to the definition of left pad, right? What left pad does is it left pads using list.leftpad. I go to the definition of list.leftpad. It's string.replicate n minus L length. Yeah. So what I actually want is, right, width size is the total width that I want to end up with. So what I want first is space dot replicate string.replicate does not have an argument with type string. Do I have to, sorry, string.replicate. Sorry, where is string.replicate defined somewhere? No, wait, it's list.replicate? String.replicate. Some integer value and then a character. Is it, sorry, string.replicate, the replicate default does not take in any character. Right, yeah, the whole padding is sort of dumb. String, which is presumably replicated that many times. Right pad with some character, sure. Sorry, string.replicate. The type takes in a natural number and a character. String consisting n copies of the character. Okay, cool. So the number of copies is this, which we will double check. Sorry, it's widths I exclamation point minus cell length over 2. String.replicate argument has type string. How do I get the character? Is it single quotes? I think it's single quotes for a character. character literal. So okay, for putting everything in a sensible way. We're going to call string.replicate again. String.replicate. What's on? What's I exclamation point minus cell length plus 1 over 2 is this. So just finally to think this through. The total number of spaces that we need to add is however long the cell is, right? Is the width that we need minus however long the cell is. So the total number of spaces we need to add is width's I exclamation point minus cell.length. And then the way that we do that is we divide by 2 twice, right? Now, if it were even, dividing by 2 twice would suffice. But if it were odd, dividing by 2 twice would make you 1 less than you had to be. So therefore, we add 1 here. Okay, so I think this is all correct. What's this? Indented. Okay, let's try again. Okay, while that's running. What do we got? Wonderful. Looks like it's center aligned. Excellent. Okay, we have this whole thing and everything is center aligned. Cool. Looks great. Now, one other thing. Okay. One other thing. It is in fact the case that what this website is telling me is that there's these colons here. You see, so so the top, I have a whole bunch of dashes here. I think this is technically fine, but it means that it won't get rendered right if I put it in a markdown file. Because in order to know how it is technically aligned, it needs needs this thing. So in order to fix that, what I have to do is the separator line. So this separator line needs a little bit of a different thing. How is this? Where is the separator line constructed? The separator is constructed here. Widths.map. So this is so I want to make a slight change here. What I was doing was I was mapping the widths onto string.replicate this. Widths.map. Okay, I'm going to need map index. Sorry. How do I get like fin size map index? This is what returns map index is just like map, except that it also gives you an index to work with. So okay, so what I have is widths.map fun w arrow thing. This is what I have. String ++ string.interpolate this. plus this. Instead, I will now say map index fun IW. That's correct, right? So, and what I will do is no, what I want is no, that's not what I want. What I want is like zip. What I want is to zip the widths. I need to zip together the widths and the alignments. Presumably that's zip, right? Widths dot zip alignments. Sorry, lowercase alignments. Zip array dot zip. Yes, that becomes that. It doesn't actually be okay. I was wrong about the index thing. What I want is the width. So I have the width and I have the alignment A. Stuck at solving universe constraint. I don't know exactly what that is. Sorry, the widths. Zip. I don't know why I would be complaining about a universe thing here. Let me just put this onto a line so it's less distracting. I have the width and the alignment, and the point is that this function needs to return if A equals alignment.left. Yeah, almost right. Then it's going to be string replicate W minus 1. But for left aligned things, we put it over here. We put a colon, so it's colon, string, colon, append this. If alignment is right, then it's W minus 1 of these. And then append the colon on the end. Else, no, that's not right. It's W minus 2. And of course, there has to be a colon in the front as well. Type mismatch. Sorry, what is it complaining about here? Application type mismatch. Array map. Argument array width zip widths alignments has type array nat. Oh, okay, I see what the issue is. The issue is that this needs to have the form of this component here. Yeah. I think that's correct. Okay, so now I will run it again and see if it works. Of course, this is it's technically a problem if there's a column which is less than like 2 long, 2 characters wide, but that seems unlikely. Okay, what do we got here? Sorry, expand to your full capability. I did not save the file. I'm going to put a little comment here which says, check the separator line with colons to indicate alignment. Okay, so now there are colons. There's a colon on the left here. There's a colon on the right here. There's a colon on the right here, and there's center alignment here. Cool. And just to confirm, right, just to quickly confirm, what I should be able to do is copy this entire thing. Copy this. I should be able to make a new file, paste it, and then I'm going to interpret this file as a markdown file. This is a markdown file. And then what I want to do is I want to mark down open preview to side. this interpret it the way it's supposed to? That's disappointing. What is wrong? What is wrong with what I'm trying to do here? File instructions, cumulative parallelisms, right? Wait, where did the the problem is that there's no like new lines between. It's blinding to see all of this. Sorry, let me just, okay. X, delete this. We're not doing this here, we're doing it here. New file. Right, I mean, it looks good when interpreted as a CSV. I would like to interpret it as a markdown document. Maybe the issue is that it requires a title. Everything is on different lines. That looks good. These are all dashes, I believe. Very frustrating that this is not working. Are you capable of rendering a basic table? Call A. Call B. Okay. What's the issue? What is the issue with what's happening? Why is it that I can see the things between the dashes here and not here? Okay, if I select all this and replace it by some dashes, and I select all this and I replace it by some dashes, and I select all this and I replace it by some dashes, and I select all this and replace it by some dashes, then it is fine. I am totally confused about why that would be the case, because this is just a dash, right? Sorry, it's a dash. Is it a slightly different character? Okay, before it was telling me it was some weird Unicode character, but now it's not telling me that. Maybe the issue is that the old file had put in some Unicode character there, which I will not be doing. Okay, we're deleting this. We're trying again with the actual dash character. Yes, great way to get your PR rejected is to just change some minor formatting thing to make it look right. Okay, like my thing is markdown compliant, but now it looks slightly worse because there's little holes between all the dashes, and so I don't think that people are going to necessarily be happy about that. If I copy all of these and I control all paste, yes, now it renders a nice table. Okay, well, that seems fine. Sure. Cool. That's great. I'm fine with that. float to string. Init data float. It's like yeah. So, well, yeah. What to do now, right? What to do now is to put all of this in its own self-contained file. And I'm like, does this go in that file? I'm not exactly sure. Looks like this should actually go in the same file as float.toString, but that is a file in init. So don't know if I necessarily want to put that there. But that's fine. I'll just put the other things in that file. So longest poll, why don't I just make a new format table dot lean. The contents of format table dot lean are going to be these. Ooh. Sorry. Delete that. Open format table. Paste this in. Of course, we need the same imports. Okay, so what are the imports we need? Copy these imports into here. Save that. Now this file is fine. I think, okay, so we need this import, this import, this import, and this import here. But the point is that now, instead of this import, the thing that we need is a longest poll.format table. Imports are out of date and must be rebuilt. Seems perfectly happy. Format table over here. So just to sorry, just to like see, like we need not that one, not this one. Okay, if this is the longest poll, we're gonna copy format table. Sorry, what's going on? MathLab data string defs. I think this is the only import we need, right? Select line, delete. This seems fine. Okay, so this is my format table file. I am required to put a copyright header on it. Cool, it's 2024. The other thing that I'm required to do is put a documentation string. Shall put here. Format table. For formatting a to-date array of strings into a table. The table markdown compliant table. Cool. So that is a new file. All right, and just to be sure, we're gonna restart this file to make sure that everything still is building. Everything still seems to be building. I'm just gonna run it again to make sure everything still runs and works. if everything runs and works, we're just going to commit this. And probably like the smart thing to do is after we commit it, what we should further do is run the benchmark thing again, so that when I get a bunch of comments on it and I go back to correct things, I can implement those comments. Analyzing MATLAB. I have a center justified table and 2 other tables. Yes, everything looks correct. So now I will return here. So this is my format table. My to-dos. Edit. I have completed making the markdown core in a markdown compliant format. Allows specifying alignments for columns. Furthermore, moves to its own file. Okay, so I'm updating the comment with all of the things that I've accomplished. This is great. Depends on something that's already done. Okay, so now what I'm going to do is I'm going to go to Git, and I'm going to say add all of the things that I have changed. Add changes, commit, sync those changes. I have synchronized all of the changes. And now it will process these, and I will mark this as awaiting review, because I think it's nice. Now, right, everything is done. Added awaiting review and reviewed WIP labels now. And finally, I will say exclamation mark bench to reflect the fact that the next time I come to this, yes, did it already pass CI? Yeah, it already passed CI because it didn't have to rebuild MATLAB or anything. Cool. So I'm just going to add the exclam bench so that it will benchmark it again, and I can come back to it later potentially. Right, cool. That was great. So we got that done. If I go back here, right, so let's yes. I feel like I accomplished that. So what have we done today? We have this work in progress thing that we added because we need this lemma and it's a really hard lemma. We added this thing to make the non-terminal simplanter more flexible. This thing depends on the format table, which we now have as awaiting review. We have the tropically bound polynomials feature, which we are not currently sure what we want to do with adding the actual polynomial list thing to that. That's in progress. Berlekamp-Welch is something we're not touching today. This thing is awaiting review. Scripts to analyze overlap between namespaces also wants to depend on the table format thing. Right, so it's an interesting question. Where will the table formatter end up? Not totally sure, but the point is that I want to use it for this too. These two things are awaiting review. Yeah, this is blocked by this. And the next thing on our docket is this thing that Golf's simp calls. All right, let's take a look at this. What is this? Golf simp calls. Successor to 9079. Golf simp calls. Ah, yes, I remember. So if I go to the files here, yes. It's a single file, which is a Python script. Okay, so what was the point of this Python script? All that this Python script, so the point of 9079 was something that was going to, so basically if you go through MATLAB and you look at simp calls to simp, or calls to simp only, for example. It is often the case that not all of the lemmas that are included in that simp only call are actually needed. And so what this PR putatively does is it's just like a tool for you to like run a lean file, right? So what does it do? Let me like go to the actual, in fact, let me go to the actual branch. Golf terminal simp. Lean version changed. Cool. Sorry, the file is scripts/golf.py. Let's see if we can find that here. All right, so we have this Python file. Redefining. It's very annoying that my linter is so persnickety about things that do not seem like problems to me, but whatever. So what this, so what does this do? The point is that like this was a very like sort of hacky Python script that worked as follows. It would take a Python file and it would it would take a lean file. It would basically go through, detect any instances of a call to a simp tactic within that lean file. It would rewrite that simp tactic, removing certain lemmas, it would try to remove a lemma from that simp call, and then it would like rerun the lean file to see if everything was still good within the lean file. And if it found that everything was still good, it would just leave that deleted. The idea being, and if everything was not good, it would add it back in. So the point is, it would only delete lemmas from simp calls when those lemmas were not needed for the proof to succeed. So I did this, and it was very nice. It was finding all kinds of lemmas that were able to be removed. But when I told people about it, they immediately told me it was a horrible idea. They told me that they were worried that when I removed some lemmas, it was actually like potentially affecting the proof state, and the proof was only going through, like what they were worried is that like I would remove a lemma from some simp call, and then the tactic state after that simp call, the state of the tactic proof after the simp call would look totally different and potentially be much more confusing, but the proof would still go through for sort of like, the reason that REFL proofs often like just go through. And so their concern was that like if you're affecting how the state looks, you might be removing things from the file, you might be golfing the file, but you might be making things more complicated. You might be making, I might be making like the tactic state more complicated. And so what they told me to do was, okay, instead what you should do is you should write something that only makes a change if the change like continues to build. Number two, the change builds faster than the original change, so that the change does not have like a negative effect on the speed. And furthermore, three, that it should only change if like you're not like affecting the actual tactic state. If it's just like a lemma that doesn't do anything and doesn't make anything faster. And so these were the like admonishments. In fact, presumably this is like, if I go here, I will see like all of these comments. This is what Kyle Miller was saying. Worry about lemmas someone added for performance reasons. Right. And of course, like the major like additional like sort of problem is that this is a Python file and I'm here in a Lean project. So all of my like contributions to like Lean infrastructure take the form of Python files that like parse the strings that make up a Lean file, and this is not the form that other people want them to take usually. That's this, like, it's this sort of the same with my like non-terminal simp linter. Okay, so I need to like add a few comments. Some comments I have received about how this should work. Yeah, let's just like completely rework this. So this script runs on a clean file or directory of clean files and removes lemmas from simp calls in those files when and if when those simp calls, when unnecessary simp calls, unnecessary lemmas from simp calls in those files. How this should work. It should not do anything. If it changes the tactic state, the appearance of the the tactic environment, the proof, I don't know exactly what it's called, the info view environment. And since people may have added unnecessary lemmas that make the info view easier to parse, to read, it's capital, sorry, what is it? Sorry, what is the command? Info view, command shift, oh, whatever. It's capital I, capital V. Info view, read. It should not make any changes that make compilation slower, since some lemmas may be present for performance reasons. Third comment, should written in Lean rather than Python. And a good idea probably for me to look at is I should look into the Renshaw's try at each step. Let me link to this project. Try at each step. Renshaw try at each step. There's definitely like a GitHub project. Try at each step, but it doesn't reference. If I go to the lake file, does it tell me where try at each step is? Yes, this one. See, it's unfortunate. Like, why does Google not find this link? So this is the link. Try at each step is a tool that runs a tactic at each proof step, right? Try at each step project for an example of a project that analyzes tactic by tactic changes to a file. So update the comment there. Okay. We have also introduced, if I put something directly above, yes, please put a blank, sorry, no, yes. Please leave a blank new line, otherwise Git will format it as a title, yeah. Add more features, cool. And there's like 9101, right, which has a whole bunch of other things. And this is like a bunch of files that have been changed. And I have a whole bunch of other things. Right, so I think this this pull request is basically the same as the other one, except that the golf.py is also in this one, and this has a whole bunch of like changes that have been made. Like, so you can see like the sort of thing that it manages to like find, right? So this will be like a good example. It's like simp only like figures out that you can remove this add make thing. There's various things that you can remove. It removes this 0m lemma here. And it is actually able to like completely remove simp from this. It just turns it into a REPL, right? So there's like all these things it manages to do, which are very nice. But I think what I want to do, right, what I want to do is like, so I have a whole bunch of to-dos, none of which have been done. Sorry, let me duplicate this tab. So 9320 is the one where it sort of currently lives. I'm going to put, so what I'm going to do is I'm going to copy all of these to-dos. I mean, I'm not going to, I mean, these are obvious things, right? These are like, basically I have a whole bunch of advice for like additional things that I could sort of golf. Yeah, and that's fine. So basically I'm going to add all of those to-dos here. Over here, I'm going to say, this is 9320. I'm going to close in favor. Number 9320. Closing this with that comment. Cool. I delete this, and now everything will be just here because it needs to be rewritten in Lean anyway, and there's all these different things that need to happen here. And it's still a work in progress. Yeah, so this is totally fine. Okay, so that's that. And it's marked as work in progress, which is fine. I'm not going to work on it more today, I think. But this is it. Here's the to-snock lemma. Right, the to-snock feature. This is another thing that is basically there's all of these lemmas that are about cons, and there's all of the like symmetric lemmas about snock. Which I want to like, I would like it if the snock ones could be proved automatically. But I don't know if that's actually gonna, that's like something that a little bit more oomph is required to do this one. This is more of a long-term one. This one is marked as won't fix. Yeah, add suggestion for splitting lines. Yeah, I agree. So basically what this is doing is like, there's the linter, right? There's the style linter, which runs on every file. And there's something you can do to get it to suggest changes. Like when you run it, like GitHub will say, hey, you should make this change so that it fits with the linter. But really, it's all sort of like, you know, really what should really just be done is a formatter should be written for Lean. There should just be a Lean formatter that could be written. And that would be nice. So I think I am, in fact, going to close this. Close pull request. Cool. Sorry. All right. So that's this one, this one. This one's awaiting review. Reverse is another one. See, this is like sort of a prerequisite for the SNOC one. Because the basic idea is that I have all of these lemmas about SNOC, right? So SNOC is when you put something, like cons is when you put something onto the beginning of a list or tuple, and SNOC is when you put something onto the end of a list or tuple. And the point is that any theorem about SNOC follows by just reversing everything you have. Finding the corresponding, you now have a lemma about cons, right? Now you just need to find that lemma about cons, use that to prove the statement you want. And so it's sort of the case that this depends on reverse for fin tuples. So this is, so if I were going to be able to write this attribute, it would be necessary to, okay, it's a little interesting. It's sort of like they're two different approaches to the same thing, right? It's like, how do I make it easy to prove a SNOC lemma given that I've proved the cons lemma already? One way is to just like make something that is, you know, just make the standard proof be like reverse everything, you know, prove it for cons and then reverse it again, reverse it back. The other way is to just like from the bottom up make everything SNOC. Like make every like cons lemma have like this attribute that like automatically generates the analogous SNOC lemma. And so there are two different ways of doing things, and I'm not sure which one I should sort of go with. There's also this default list one, which is like pretty dead at this point. And at the very end, there's the Schwarzschild lemma. Right. This is another one. Like this is some PR that like asks to prove that a composition of two like polynomial time Turing machines is a polynomial time Turing machine. That would be nice to have, but I've also marked it as a good first issue. I think it's like a nice self-contained issue that someone could maybe adopt. And I have this Golfer for Simps. I feel like this one should be closed in favor of, like, is this just like yet another one that has the like simp golfing? Yeah. It was like 93-20, right? Close in favor of number 9320. Golfer for Simps is basically the same, yeah. So that's cool. That can be closed. And then there's this last one, the Schwarzschild lemma, which maybe I could like go. It's still waiting on it on like one other dependent PR, but there's still other things that maybe need to be done here. So like if I copy here, I mean, one thing is it's not building, right? It's like the build is failing, presumably. And I think that the reason the build is failing is because it still references algebra. It still references like data for polynomial. Let me just... Schwarzschild. Yes, Schwarzschild. Git ignore is open and Schwarzschild is open. Things are crashing all around. Thank you. No, I don't. Goodbye. Okay, so yeah, what should happen here? The problem, like the primary problem, is that these. Okay. Okay, one thing that I believe that this has gotten merged. If I click here, yeah, sorry, I mean it opened in Chrome, not Firefox, but that PR has been closed. So what I can do, okay, let me just yes, pull from origin master. Lean version changed. We'll sync again. Okay, that lean version has changed now. Then I can restart lean. And it's not building, so I'll fetch the matply build cache. So one obvious thing that I need, okay, the obvious thing that I need to do is that these files have been moved. So they're now in algebra. So MathLab build cache is going to build a bunch of things. Right. Yeah. So apparently in a previous thing, I moved this to algebra, but I have not yet done the thing that moves the other stuff to algebra. Okay, cool. So now Schwarzschild is compiling, and the theorem, I think, the theorem itself, I believe, is compiling. Yeah, there's no goal to solve. Cool. This is a little weird that there is no goal to solve, but that's cool. So this is good. One thing that I feel it should definitely be complaining about. Okay, sorry, let me... Is this was added, but it's not complaining that there's a name conflict here. Let me like move this up here. So here's the thing. So this was merged. It's probably, yeah, support non-empty. So MV polynomial support non-empty. So the name, the point, if I find the name, okay. Also, apparently it's, apparently this lemma is not used. Sorry, is support, did I use, find? Okay, I'm just totally mystified, but apparently, apparently it's fine. I can just delete this. Save. So like it was unused. Delete. Unused lemma. Cool. Like another nice thing. So this one is still these guys are still in the process of being pull requested. These lemmas I'm not sure what to do with. Section find home. Like one nice thing to do perhaps would be to add all of the references. So that's like the Schwarz-Zippel lemma was proven by like independently like at least four people. Schwarz, Zippel, DeMillo, Lipton. If I go back over here, Schwarz, DeMillo, Lipton. Okay, well, like one thing that I can change is that names have capital letters in them. Okay. Discovered independently by at least 4 different people. Maybe these DeMillo and Lipton came first, but Schwarz and Zippel were maybe more general. Let's like find the reference. Schwarz, here's okay, here are all of them. And it puts like a name here. Ooh, lightning outside. Here is the Schwarz one. Here is the DeMillo Lipton one. Here's the Zippel one. Here's another Zippel one, but I guess this one is the original Zippel one. Effective polynomial computation. Okay, so the main thing that I want to find. Save. What, like the main thing that I want to like, there's some like standard way to like if you have references to include. If I go to the community, like this one, if I somewhere there's a way where it talks about like how to code style guidelines. This one seems right. Module docstrings references. So at the very end, I can put a bunch of references. So here we go, references. And what I can do, the thing is, you see there's this, but there's like a, somewhere in the files, there's like a, a big thing of references. Maybe it's like a .bib file? It was definitely the case in MATLAB 3. Does it not exist in MATLAB 4? Bors, docs. MATLAB. Docs. References.bib. I think it's here. So it needs to be, they need to be added here. Okay. And it's all wonderfully formatted. Look at it. To normalize. It has a nice command that I can run to normalize things. Okay. And I bet it'll even like alphabetize things as well. Preserve, okay, preserve key case, preserve keys on, pass comments, print use, docs references.bib, object docs. Preserve key case on, preserve keys. Okay, we'll see. We'll see. Okay, let's let's add some things to the bib file here. Okay, so first of all, the DeMillo-Lipton. Okay, yes. DeMillo-Lipton letter, so it's an article. Or maybe a hashtag letter at letter. Seems reasonable. So it looks like the format that we're going for is DeMillo underscore Lipton underscore 78. No, it's the full year, 1978. Author. DeMillo, sorry, DeMillo, comma, sorry, we'll just copy this. Ooh, can I copy? Author is DeMillo and Richard J. The title is a probabilistic remark on algebraic program testing. The journal is Information Processing Letters. Yeah, like it's a letter. Is it an article? Maybe I should just call it an article. Cool. Volume 7, number 4, pages those, here's 1978, DOI is that. Yeah, it doesn't have anything more to suggest. Cool. That looks right. This is why we use the AI for these things. So it should sort, the thing is it should sort by the name. Let's like further add, let's add the other ones. So the other one is this one. Schwartz, 1980. Schwartz, Jacob T. Fast probabilistic algorithms for verification of polynomial identities. Journal of the ACM, 27, 4, 701 to 717. 1980. DOI. Did it hallucinate that? Wait a minute. Oh no, there's more. Sorry. The DOI. Okay, well it got the DOI right, so I don't need to copy it in. That's fine. Cool. Sounds good. I think I've got everything right there, right? Maybe one change is that they want whatever. That looks is fine. The last reference is this Zipple paper. No, not Solveig Strassen. Zipple, 1997. Zipple, Richard. Probabilistic algorithms for sparse polynomials. Symbolic and algebraic computation. International Symposium. Maybe book title is what it's called. I don't know. International conference, right? So it's like if it's a conference, it sometimes goes by book title. So, like weirdly enough, I think the AI is right about this thing. Series, lecture notes in computer science. 72. DOI, ISBN. Probably all these are right. Just gotta check that it didn't mistranscribe. Yeah, that looks fine. Okay, seems good to me. So to normalize, well, will this alphabetize everything that I need to alphabetize? Let's find out. I'm gonna paste this command and run it. Hope it didn't just delete everything, but it looks like it didn't. Okay, wait, totally weird. It moved the header, which it was not wanted to do. Please don't do that. The header should go back up here. Sorry. Okay, apparently there's like no gap here. What is it saying I deleted? Revert change, please. Oh, yeah, okay, cool. So just make sure. This goes here. This goes here. We have another one down here. That seems fine. Okay, so we add the references. And we'll just add some references here. So the names of the references we just added are DeMillo, Lipton, 1978. Sorry, was there like a special format? Okay, that's not right. The hallucination is not correct. What we want is the Schwartz 1980. The Zipple paper is from 1979. Yeah, okay, cool. So we have added the references. Cool. I'm happy with that. Let's add references. Those changes. All right, very good. So yeah, all of these lemmas are fine for now. I mean, we could do a little bit of golfing potentially of the actual proof. Like, I don't think I've gone through and actually, like, golfed the proof itself. Does rewrite work under binders? No, it doesn't, right? And like, okay, so another comment is that, are we creating extra goals here as we go along? Looks like we're not, actually. There's also like a bunch of like random comments interspersed throughout, so I have to like see what are the good comments and what are the not good comments. But for example, right, can I just like do show term here? Show term to like golf this a bit. Exact this. Right, so I'm doing by exact. In fact, if I really want to, I can do like this. So there's like plenty of, I can probably do show term here too. Show term. And it's going to tell me exactly what I can do. Can I combine these two simp only calls? You would think you would be able to combine two simp only calls, but often it's just not the case that you can. Well, looks like I can. Seems good. Okay, that's cool. I guess I sort of wonder, would this be off as like a simp call? Let's set filter and. I wonder if the problem is that I'm like simplifying when it's function A, PA, QA, S, filter S. The problem, is this a simple? No, it's not. Yeah, just this long calc proof. Sort of trying to like explain what happens at every step, right? This is the thing that corresponds to the probability of A. This is the thing that corresponds to the probability, like we've split it into A intersect B and A intersect complement B. This is less than B, right? So A intersect B is less than B. And we have some complicated proof. And then finally it gets easier at the end. I'm also noticing that there's like there's unnecessary parentheses here. A lot of things could probably be golfed. Just lots of like random golfs here. See, we do massive simp only here. I mean, like one question, HPR 0. What is the what exactly am I simplifying with here? Right, so I'm reverse simplifying that. It suggests that I could potentially Why is it saying imports are out of date? Sorry, can I? It's saying I need to restart my file. Hopefully nothing breaks. Yeah, nothing breaks. Okay, but if I'm, can I do this with rewrite? Yeah. So wait, we're trying to prove PR coef 0 equals 0. HPR 0 says PR is 0. The reason we can't do it backwards is because we don't know what 0 is. Coef 0. Polynomial.coef 0. Is this even necessary? Sorry, what does it start out as? PR coef 0. What? PR 0. Yeah, so the coefficient of the point is we need to know the polynomial. It's the 0 polynomial, right? We need to know it's the 0 polynomial, and then we're done. HPR 0. PR. P prime. Where's P prime defined? P prime defined as P. Coef map. Polynomial.map coef n. Is this because that is defined essentially as a map? What happens if I move this here? Rewrite factailed. So this is a polynomial, and I guess the point is that we're arguing PR is defined as polynomial.map. Like, we've proven that PR is 0, presumably through some like labor. And now we like proceed. Yeah, just like really sort of ugly, this whole section. I think that like we can delete this, right? At least. And we can probably do show term here. What I would really like to do, so like one thing that I've sort of thought about is that like it would be good. I have like a thing on the forum about this. Let me like pass through equivalence. Load more. I have no idea what I'm looking at here. I want to like rewrite through the equiv. I want to go sent by me. Rewrite equiv. There's like all public streams. I want to rewrite through, pass cleanly through an equiv, because this is what I'm doing. I state has this p polynomial, right? I would like to be able to pass through. So I have this equivalent polynomial. I don't care that p prime is defined based off p, since for the rest of the proof I only deal with p prime. So I would like to forget p, replace every reference to it with a reference to p prime, and then remove the clutter from the state. And this is what Alex Best suggested. Suggested to set p prime. Clear set. Yeah. So yeah, just to expand this. The point is that I'm somewhere around here, right? You can, like, the whole point, I'm at the beginning of the inductive step, right? And I want to consider p as a polynomial over multivariable polynomials with one fewer variable. So I define that polynomial, which is p here. Finn-Sucker-Quiv, right? So I set that. P prime to be this. What is Alex suggesting? Right, P is a multivariable polynomial. P equals this. Rewrite P equals at HP. Right, so he's suggesting I do something first. Intros P. Right, so I have my multivariable polynomial P, which is in the state. I don't think I use PEQ anywhere, so the point is that I do this. Okay, well, first of all, I'm going to, like, before I mess up my perfectly building function here, I'm going to commit all of the golfs that I made. Golfs. Sure. What do you suggest to do first? So the first thing I do is I establish that P is equal to the sim applied to the reverse equiv applied to the equiv applied to P. By sim apply, true. Then, so I now have P sub EQ in my state. I would like to what I would like to now do. So it doesn't need to be done in here, because this is a different P. This is the inductive hypothesis P. P is this. P non-zero is that. I would like to mostly just do it at P sub non-zero. P non-zero. Right, I do it at P non-zero. And then the further advice the point is that this comment should go up here. Call this polynomial P prime. Call this polynomial P prime by setting it. And I think I don't have to include the width here, because what I'm told to do next is clear value p prime right, which tells it to forget that p prime is defined in the way it is. Now forget about p and work with p prime by clearing those values. Right, so now we just have p non-zero. And what he recommends next is simp add star. Right. The only thing it rewrote, simp at p non-zero. I think the only thing it touched was p non-zero here. Simp question mark at p non-zero. This looks right. I mean, I feel like I want to keep it in the same form. So any eq is not something I necessarily want to operate with, but I do want to operate with this. Why does it make no progress here? What is any eq? Okay, we have to wait for it to recompile for it to figure anything out. Yes, unknown item fire. So not e, like not eq. Map equals 0 if x equals 0. So I think what we really want is rewrite with that, and then maybe go in the reverse direction. Any eq. I wonder if there's special syntax for this, but right. So now we just have p prime as non-zero. Finset.filter. The weird thing is, why does H0 reference P? I guess everything else still references P, but I don't want it to. The point is that we're still, like, even though we've even though we're thinking about things in terms of p prime, we still are sort of we still have the thing here, right? So I guess maybe the point the point is I haven't really like simplified things for myself. Sorry, the point is that if I like take this and I go and I find every single instance of the place where P is and I replace it, in theory, I can deterministic timeout. Joy. Huh. Is it timing out because there's a problem, or is it timing out because of some other reason? Yeah. All right, the point is simply that we have to do this. F dot total degree. Pi prime is p dot cof I. I is the non-degree p. I feel like I've like moved myself to the sort of wrong type somehow. I feel like the reason it's if I say like convert. Okay, but this is usually not what it looks like when a convert succeeds. Yeah. I think maybe the issue is that like this the issue sort of is that this lemma is phrased. I think I probably wrote this lemma, right? I think this lemma is phrased in terms of Finnsuckaquiv, the forward version, whereas I am now needing it to be phrased in terms of the sim version. Yeah. Yeah, it's interesting. It's interesting to see how things sort of get duplicated. Yeah, this seems like a challenge. Seems like a challenge indeed. Okay, so just for like curiosity, if we sorry this out, will it continue to complain farther on in the future? Exact. PI is non-zero. Okay, so like fascinatingly, I can do this. And now, yeah, so now it's like start taking me through the rigmarole of like I have to replace this everywhere I see P, right? But I wonder if it's like not actually a problem. It's just I wonder if it's gonna tell me again that it can't. I wonder if it's gonna tell me again. Okay, no, it didn't complain at all there. What happens if I just keep going? This will be interesting to see. Like massively ungulfing things here. Just every time I see a P, I'm pasting this. Making the proof entirely unreadable. Unknown identifier HP prime. think the reason unknown identifier HP prime. Sorry, is that what it was called when I had my P prime, the set? With HP prime, yeah. So that's what that lemma was called. So now that that lemma, like in theory, this lemma now is totally should not be needed. We can remove that. The point is now that I'm going through everything. Everything, yes, HP prime does not exist. I simply delete it because everything is now defined through HP prime. HP prime thing does not exist. HXR did not find instance of pattern. Intros something in HXR. Okay, so it looks what I'm observing here is that I have finsuck_equiv finsuck_equiv sim. So can I simp at HXR? Some question mark maybe? Because it's sort of like, you know, it's sort of, I'm doing sort of weird back and forth. I need to like sort of pull the thread through the cloth, pull the loop of thread out. Okay, seems totally comfortable with that. And no errors. Unknown identifier P, okay. Paste. I should just go through and paste. Gonna complain here too. Paste. And it's also gonna complain here. Paste. But the whole thing is building, except for the one sorry that I need to fix. Sorry, if I revert this. Now it's not building. It's so funny how it takes longer when it's not building. It must be like trying really hard to figure out what the right error to say is. Okay, my next order of business is it complains about like timeout, right? It complains about some form of timeout. Can I simply deterministic timeout? Maybe if I simply provide the value of P, right? So the value of P, of course, is this F value, right? So finsuck_equiv. Right, so sorry, finsuck_equiv going backwards gives me, yeah, so like this. If this doesn't work, I'll just try deterministic timeout, maximum number of heartbeats. Set, okay, we're gonna try set option. We're gonna try a set option here. Set option max heartbeats 0 for no limit. And this will possibly take forever. Sorry, where was the, this is the line that is causing me trouble. What is it complaining of? Tactic applied to failed to apply. Can I say I here? Is the other value that it should take? Sorry, what is it? Failed to unify. Failed to unify. failed to unify this with that. Okay, but the reason you failed to unify is convert. The only reason it failed to unify is that it was there's like a third thing that's sort of analogous to apply, and it's a different one. I need to go to the list of tactics. Tactics. Here, this one. List of all tactics. See tactics.md. Okay, this one here. It's up here. Oh, what is it called? It's not convert. Change. No, but that only works for definitional equality, and I don't think the things that I'm looking at here are definitionally equal. Sorry, what is the convert? Convert. Refine, that's it. Refine E. Not required to exactly match the goal. Instead, new goals are created for differences between the type E and the goal using the same strategies as conquer. Yeah. So I'm calling this function and the problem is that I need an additional argument here. The problem, yes, what exactly is the full version of this function? The full version of this function is that it takes an f, an I, and it also something called hi, which says that that value is not equal to 0. I'm basically like reversing the work that I just did. Okay, sorry, what is it exactly that I need? So f is the thing with the sim at the end. Have hi is this. Sorry. Who knows what R is? I mean, it shouldn't be R, it should be F, probably. And instead of F, it should be the thing that I replaced P with, which is this bad boy. Should be this, right? By sorry. And hi is the point. It goes here. Can I like simp this away? Simp. Apply, simp apply. No goals. So wait, so it's literally saying there's no goals, so I can just comment these out. Yes, no goals. Okay, so what did we like? Okay, and finally, let's like clear this sorry now. Sorry. Can we like just simp simp only this. What do we need to do? We need to rewrite HPI prime in reverse. We need to do this. And then when that is done, wait, what are we doing? P cof I is equal to 0. Oh shoot! The problem is I sort of like deleted the logic or something. Pi prime. Pi prime is defined as p prime dot cof I. So we're saying p prime dot cof I is not equal to 0. What was it? What did it look like before? I need to use polynomial dot leading coef somehow. Because the point is that I is the leading coef. Yes. Coef I. I is the nth degree of P. It's the leading coef. Apply polynomial dot leading coef not equal to 0. The point is that I can simplify, like this is the leading coef, right? Rewrite HI. I rewrite HI, and it's p prime dot coef. I can simplify this. Surely I can simplify this to say something about like this is what is called the leading coef. Coef dot nth degree is a theorem that tells me that I have the leading coef. Polynomial dot leading coef is 0. P prime is not equal to 0. Exact P non-zero. No goals. Delete. All right, cool. And the whole proof is building again. Some linter is telling me I have an unused variable. Okay, so I've reworked the entire. Okay, this is very nice. Okay, I need to like get some like food or something though. So I'm going to like take off and try and microwave something. Okay. Ugh. Fair warning to anyone listening, this is about to get very into me chewing food. So, prepare your ears. Right, so our entire file is compiling, which is good. And we have done the thing initially suggested by Alex in this thread, which is to use that, use the fact we don't have to refer to P anymore. Add emoji reaction, check mark. Okay, the consequence is that our proof is longer, probably longer now. Unless we have a bunch of instances of this thing. So, I mean, my intuition somehow is that these things can be removed. So, this one I get is present because we're invoking HO, presumably. Right, so we invoke HO here. H0 there. Because we have this structure. That then takes us... Okay, so this is first half, right? We have something called first half. Clear H first half. Yeah, it gets very... The structure of this proof is a little bit complicated. There's something that said... There's a philosophy that said I should identify where first half is. I used it 3 times. One is me just clearing it because I don't want it there. And the second time is me using it here in this thing. It's sort of weird that I use it towards the end. You would think I would use first half in the first half. Does not make a lot of sense to me, but okay. Lots of things. I mean, this is the key structure. So the point is is there any place where I can use that where it's not going to actually be Finsakakwev? Alright, so I have to use it here because I'm doing Finsakakwev. Simp that away. Does it make this stuff more efficient down here? Is the question. The issue I'm sort of identifying is that we do all this like evaluating of R, where R is this where is R? R is introduced here. Finset.card. Like I think the thing that one would have to sort of figure out is how can we like rewrite all of this in terms of like R is fin n. See, sometimes R is fin n and sometimes it's not. Very complicated. I'm not completely convinced. But like we did all that and now I'm not like completely convinced that this is like actually any clearer. It's like we start out here, we do all this, we clear that, now we have our P prime. Fun F. Evaluate the fun that takes F and evaluates F here, where F is this. Right, the key, the thing that would have to be done see, we do all this, and then we like continue with the rest of the proof. I feel like the important thing to do here would be something along the lines of, like, now that we've gotten this sort of sim thing out, we now need to like transform F. Where is F even defined? This function over F. The point is that we're filtering over F. We need to transform this filter over F into a filter over like the component parts of F, right? We need to like the head and the tail of F. Filter over the head and the tail of F such that that goes there, and then we could like decompose. Because if I look at the rest of the proof, this is like the Schwarzschild lemma. This is the proof. The whole thing is like conditioning on this B event, which is some statement about what happens on the tail. Yeah, so there's like a whole thing that can be done to restructure the proof. Maybe what I want to do, like I'm not sure how I want to proceed, so instead I'm just going to I'm going to copy this down here. Wait, I'm gonna copy that out and save. I'm going to revert the file. Then I'm gonna paste it again. My second Schwarzschild, like Schwarzschild, this is like the version where pass through equivalence version. It's like a different proof of the same theorem where I pass through the equivalence. And the point is that in theory this should be more efficient if I like golf it through. I'm gonna say add different proof version. Commit this. All right, that seems good. Like reload this. Presumably this is all building. Maybe it'll get mad at me for having lines that are too long. Seems like a distinct possibility. I think it's mostly okay. If I return, yes, lint is getting mad at me, but that's okay. I have the Schwartz lemma. It's still blocked by some PR, but that's fine. Let's see, what else can I do? There's also like one sort of final thing, which is not, I guess. Do I want to work on my like type 1 proof systems? Maybe I'll do that another time. I'll like consider my work for today done. Right. That is it. Stopping recording now.